In this video, we'll prep for exponential and logarithmic equations by doing a quick review of logarithms and some of the properties of logarithms. Now, like with what we've done in other videos, not only will we do a quick review, but we'll try to show you how do these topics relate to what you'll see in a college algebra class when you talk about, in this case, exponential and logarithmic equations. So the first thing is the reminder, the definition of the logarithmic function. Now remember, a logarithm base b of a positive number x satisfies the definition that y equals to log base b of x is equivalent to b to the y equals to x. So that the base of the logarithm b is the same thing as the base of the exponential, and what the logarithm is equal to, the y, is equal to the exponent needed to raise b to get x. So x is what's inside the logarithm, and it's what the base raised to the exponent is equal to. So for these first two examples, let's rewrite the following equations. So for the first one, we have this exponential equation, e to the x equals to 4. And I want to rewrite this because this is in exponential form. Let's rewrite this in logarithmic form. So our base in this case is e. So the base of our logarithm will also be e. Now remember, a logarithm with base e is the natural logarithm, and we write it with the ln. So we'd have ln. And then what the e to the x is equal to, the 4, that's what would be inside the logarithm. So the natural log of 4 is equal to the exponent we need to raise e to get 4. So that'll be x. So that's rewriting this exponential equation in logarithmic form. Now the nice thing about this is that we now have actually solved for what x equals to in this exponential equation, that x equals to the natural log of 4, and you could plug that into your calculator and get what is that actual value. So this gives you a little insight of what we will be doing when we're trying to solve exponential equations. Now let's look at this logarithmic equation. If we have log base 2 of x equals to 3, then rewriting this in exponential form, so the base of our exponential is 2. And remember, what the logarithm is equal to is the exponent needed to raise 2 to get what's inside the logarithm. So in this case, our exponent is 3. And what that's equal to is what's inside the logarithm, so that'll be x. So rewriting that logarithmic equation in exponential form, we get x equals to 2 to the third, so we get x equals to 8. So we actually did solve this logarithmic equation, because remember, to solve the equation means we got to find what are the values for x that satisfies the equation. Well, in this case, if we plug in 8 in for x, we'd have what? Log base 2 of 8. So 2 to what power gives me 8? Well, 2 to the third power gives me 8. So we actually did solve this logarithmic equation. So it's by using just the basic definition of logarithms that we could solve these exponential and logarithmic equations, although these were very basic exponential and logarithmic equations, that we're going to have to do things to other exponential and logarithmic equations to get them into this basic form. Now, one of the things we'll have to do is to use the different rules of logarithms. So let's go over the three basic ones. So first, there's the product rule for logarithms, which says the product rule for logarithms can be used to simplify a logarithm of a product by rewriting it as a sum of individual logarithms, or vice versa. So if we had the sum of individual logarithms, like log base b of m plus log base b of n, that's equal to the log base b of m times n. So that was, as you recall, the product rule for logarithms. Now there is a quotient rule for logarithms, which can be used to simplify a logarithm of a quotient by rewriting it as the difference of individual logarithms, or again vice versa. So like if we had log base b of m minus log base b of n, that's equal to log base b of m over n. So that'll be useful for, again, when we're solving these logarithmic equations. Now, the third basic rule of logarithms is the power rule for logarithms, which can be used to simplify the logarithm of a power by rewriting it as a product of the exponent times the logarithm, or again, vice versa. So that n times log base b of m, what we could do is move that n in front of the logarithm to the exponent, so that'll be log base b of m to the n. Now, when you first might have been learning these rules of logarithms, you're going, okay, what is the use for this? Because it's hard to see, because often when you're first taught a lot of things in mathematics, you don't see the actual use until later. Well, one of the uses of these rules of logarithms is to help solve logarithmic equations. Now, so let's look at a couple examples where we have a logarithmic equation, but all I want to do is to rewrite the left-hand side of the equation as one individual log. Because right now we have log base 5 of x minus 3 plus log base 5 of x plus 1 equals to 1. So right now we have two logarithms, or two logarithmic terms on the left side. So let's combine those two logs into a single log by using the product rule for logarithms. So for adding those two logs, remember that's the same thing as the log of the product. So this would be log base 5 of x minus 3 times x plus 1 equals to 1. So we rewrote this sum of those two logs as one individual logs, where we take the product of their insides. Now, again, I like to give you a little insight of why did we just do that? Well, we can now use the properties of the definition of the logarithm, like what we did before when we had this one single log equal to this number. Then we could rewrite this in exponential form. So this will be 5, because the base of our logarithm is the same thing as the base of the exponential, raised to what the logarithm is equal to, because remember what the log's equal to is the exponent. So 5 raised to the 5th is equal to what's inside the log, the x minus 3 times x plus 1. So we now have this equivalent equation, and this is actually a quadratic equation. You would multiply out the right-hand side, subtract 5 from both sides, and then you could solve that equation. But the nice thing is, when we did this, that our original equation had logarithms in it, but by rewriting it this way, we no longer have any logs. So this makes it easier to solve. Now, similarly, for this second example, if we have the natural log of x minus the natural log of x minus 1 equals to the natural log of 2, again, rewriting the left-hand side, remember when we have the difference of two logs, that's equal to the log of the quotient of their insides. So this will equal to the natural log of x over x minus 1 equals to the natural log of 2. Now, how this will be useful for us is if these two natural logs are equal to each other, and they're the same base because they're both natural logs, then what's inside the two logs would equal to each other. So we'd have x over x minus 1 must equal to that 2. And so we could now solve this equation using basic techniques. But again, the nice thing about rewriting it this way is that we no longer have logarithms in the equation. So that's some of the stuff you need to use to solve basic exponential and logarithmic equations.